In this video, I'm going to provide a complete introduction to shader graph. During this video, you'll learn how to make a shader graph, how to apply a shader graph to a material, how to expose shader graph properties, how to sample a texture in shader graph, and how to use shader graph's Fresnel node to outline your model. I included the final project files in the link in the description below. We'll start by opening the Unity Hub. The first thing you'll need to do is create a new project. We prefer to use 2022.3, and we'll use the universal render pipeline, which is the best pipeline. So we'll go ahead and name it. Let's call it shader graph introduction, and then we'll create the project. Okay, so we now have our sample scene open in Unity URP 2022.3. The first thing we'll need to do is create a shader graph asset. To create the asset, right click on your assets folder, go to create, shader graph, URP, and we're going to create a lit shader graph. You can see there are a lot of different types. We won't cover them in this video. It'll create a new shader graph, and we'll call that our new shader graph. Then we can go ahead and open that. Let's take a few minutes to quickly go over the user interface for shader graph. The panel on the top left is your blackboard. The blackboard contains a list of all shader properties, both exposed and not exposed. Exposed shader properties will appear in your material editor. Non-exposed shader properties won't show up in your material editor. Click on the blackboard button on the top right to close that tab. The next section is the graph inspector. This consists of two tabs, the node settings, which will show up if you have a specific node. You can see here that once we add in this UV node and then click on it, the node settings show up. It includes two options for this particular node. These two options include the precision and the preview. So you can choose whether you want to preview the 2D or 3D version of this node, and you can choose what precision level. So this is talking about whether you want to use floats or half precision. So close that for now. In the graph settings, you have some options as well. Precision here is by default set to single, so it's like a float. You can choose your target settings. The active targets decides which render pipeline this is compatible with. So if I add in built-in, this graph will also automatically be compatible with the built-in pipe. If you have VFX graph installed in your project, VFX graph will also show up as a potential target. And then when we look at the different material settings for each target, you can see when you add a target, there are a bunch of different settings that show up. For the universal, there are some options like lit, custom, lit for sprites, sprite unlit, full screen, decal, sprite lit, allow material overrides, the type of workflow, whether you want specular or metallic. The surface is opaque or transparent, the render faces, the depth writing, depth testing, alpha clipping, shadow casting, shadow receiving, LOD crossfading, fragment, normal spaces, clear coat, custom editor, GUI, binding. In general, you don't have to worry too much about these different options. The main options you will need to worry about is the surface type. If you want to switch to a transparent material, you need to do it here. The render facing, if you want to render both front and back faces. Alpha clipping, if you want alpha clipping enabled, and then casting and receiving shadows. Clear coat lets you add an additional coating layer on top of the material. This is really good for things that have a clear coat layer, like cars. We'll leave that off for now. So this is the main preview. This shows you what the model looks like. If you right click, you can choose different options for the model that will showcase how the material looks. This makes it easy to preview your changes in shader graph without jumping back into your project. For example, if we change the color here, you can see that the color of our preview will change as well. And then whenever you finish making changes, you can press Control S or click Save Asset to save your asset file. So that's a quick overview of the user interface for shader graph. Now we'll get started with a walkthrough of how to actually use shader graph. The first thing we'll do is we will apply the shader graph to a material. To do that, we need to create a material. So we're going to go to create material, call it our custom material. And then you have two options here. The easier one is to take this shader and then click on it, drag and drop onto the material. You can see that once you've done that, if we click on that material, it's now using this shader graph shader. You can always go back here to your shaders dropdown and then navigate to shader graphs to find any shader graphs that you have in your project. So you can see that there are already some shader graphs present in this project. We want this one, our new shader graph. Now we'll learn how to expose shader graph properties in order to allow you to edit the shader graph material from the material. So you can see here on the right side, the custom material settings are all blank. You can customize these advanced options like the queue, sorting priority, GPU instancing, and GI, but the surface inputs are all. If you look back at our graph, you can see that this graph does have different options, the base color, the smoothness, emission, AO, and metallic settings. You can drag and drop these, but they're not exposed in that. So to expose them, you'll go up here and click on Blackboard. Then you'll click on this window this little plus button, and then you'll choose a type that you want to expose. So for example, let's say we want to expose our base color prop. To do that, we'll click on this color option and then call it base color. You can see that it has this little green dot next to it. That indicates that it's an exposed shader property. You can see that by going to your Graph Inspector. The Graph Inspector will show you more information about the selected node or property that you've exposed. So when you click on it, it pops up in the node settings tab of your Graph Inspector. By default, we probably want to use a white color for our base color. We do want it exposed, so that's good. And the reference is fine. That's used when you're trying to set shader properties from script. So for now, we'll go ahead and click save. The problem is that this property isn't connected to this option. To connect it, you just drag and drop it into your project and then click on this pin and drag that pin into the base color. We're going to take a look at it in our scene. So I just clicked on the cube and then pressed F to zoom in on the cube. And to apply it, we want to open our mesh renderer materials options and then drag and drop custom material into the material slot. Then we can double click on our custom material and we can now see that our surface input is exposing our base color option. So now if we want to change this, we can make the base color red. And if we go back here, we can see that the default color is still white. So if we create a new material, we'll call it our new custom material and apply our shader graph to it, you'll see that the default color is what's used when you initialize this. That's how you expose one property in the Blackboard in the material inspector. You can see that there are a bunch of different types of properties, including floats, vectors, colors, booleans, gradients, textures, cube maps, matrices, keywords, sampler states. Some options are not capable of being exposed in the material editor. So for example, you can see this one, the gradient option. Unfortunately, you can't expose it in the material editor. Some things you'll need to jump into Shader Graph to change manually if you want to customize them. So now we want to look at how to sample a texture in Shader Graph. It's a little bit unintuitive because it's a two-step process, but it follows the way that you sample textures in the underlying HLSL coding. So to sample a texture, we'll probably want to create a shader property for our texture. Maybe we want to name it, so we'll call it base color map. And you can see that that updates automatically here. Now, you can't just plug this in directly because it's a texture. So in order to get color of that texture at each point on your surface, you need to sample that texture. So to do that, we'll open the Create Node menu by just clicking on this pin and then dragging it out onto the surface, and then type in sample texture 2D. This has really handy autocomplete. By default, if there's no texture here, it'll use a white texture. You set this to black. If there's no texture here, it'll use a black texture, gray, normal map, linear gray, and red. So these are useful for a variety of different contexts. Typically, white is fine for most use cases when you're trying to sample a color texture. You might also want to offer the option to use tiling and offset. Now we want to take this color texture and we can plug the output into our base color. Now our base color isn't being used. So if we made this red, for example, you can see that it's not being received by our base color here. The standard way to blend a base color map with a base color option is with multiply. So I'll show you how to do that now. Basically, you take this pin from the RGBA output, drag it out, and then let go until you see the create node, and then type in multiply. For this case, we'll choose the multiply A input. By default, it populates these different values, the X, Y, Z, and W vector with 2, but we really want to use this base color instead. So what we're going to do is drag and drop the base color input into the B port for the multiply node. Finally, you'll take the output of the multiply node and plug it into the base color. Now, when we go over here and change the color, you can see that that color is being applied together with the map. Help highlight this, I'll include a texture from the project. Let's find something simple. That one's perfect. So we can use this knob texture as the default. And for our base color, let's set it to something kind of bright pink. That way we know we're using the default color. Let's go ahead and minimize that. And then we'll jump back into our scene. So you can see that here that our base color of our material that we had created before, it didn't update when we changed those defaults. So you can see here our default is this bright magenta and our knob, but the color here is our base color and an empty map. That's because once you've set up the material, any changes you make to the default won't also be applied to the existing materials in your project. So let's go ahead and find that knob here. and apply that. Perfect. So now we can see that this shader is being applied to this cube. You can apply it to any type of object as well. So for example, let's go ahead and bring in a sphere and let's apply our custom material. So we now have a cube and our sphere, both using the same material. In this material, we can hide these preview inspectors to clean up our graph. So we have our base color map, which is a property. We're sampling it to get the color texture at each pixel on the surface of our object. Then we're multiplying that by our base color, which is a constant for the whole material, to get our final color, which is a tint of our base color map by our base color. Plug that into our base color output. Okay. Finally, we're going to learn how to use ShaderGraph's Fresnel node to outline your model. This isn't really the perfect or most precise way to outline a model, but for things like spheres, it works fairly well. So first we'll take a quick look at what the Fresnel node does. So in your shader graph, click an empty space and then press spacebar to open the create node option. You can also right click and click create node. Then look for Fresnel. This is a preview of the Fresnel node and it's being applied to a spherical shape. To preview this in our main preview, we'll just drag it over here and then click sphere. You can see here we have this sphere and the Fresnel node is applied to it. The way the Fresnel node works is basically when you are facing a mesh head on, then it will return a value of 0, which is black. And when you're looking at a grazing angle of the mesh, so somewhere where the mesh is almost facing away from you, then it'll return a value of 1, so white. We can use this power value to push the value further away from the center, pull it in towards the center. So this adjusts how the fall off works between the 0 at the center and the 1 right at the edge. For an outline, we want something pretty harsh. So we want that edge to start pretty far away. Let me go ahead and change this base color to black and change the smoothness to 0. So we have a nice, perfectly rough black mesh here. And then we can apply this to the emission slot so we can really see what's happening. You can see that this is pretty close. I mean, it's kind of outlining the object, but it still has this fall off as you get further away from the edge. Now, the way that we're going to solve that fall off is using another node called Smooth Step. Smooth Step lets us interpolate between 0 and 1 based on an input value. So we're going to go ahead and plug this one in. You can see not much has changed yet. So the way that we're going to do this is we're going to say if the value is between 0.49 and 0.5, then that's what we want. To get the perfect outline we're looking for, we're going to take this power and bring it pretty high up. And we probably want to be able to set a size of that outline. So we're going to expose this power option as a property. To do that, we grab the power, drag it out, click float. This creates a new float input, which by default is set to 0, but we know we want something like 3. And then right click, click convert to property. Then if you open your Blackboard, you can see it's created a new float property. We'll call that outline thickness. These options we'll leave. No need to expose those. We don't want to overcomplicate our shader with a lot of different material options. What we might want to do though, is we might want to add some color options. So we're going to add a color here and we're going to say outline color. And then we can drag this and we can take this smooth step output and we can tint the smooth step output by our outline color. So the way that we do that is by using a multiply node. By default, our outline color is black. So you can see when we multiply it, it tints it to black. So the way we change that is by opening the graph inspector, changing the default color option. Finally, we're going to go ahead and plug this back into the emission node. Now we've got all of that set up, and then we can drag and drop our base color back into here. And now we have this really simple, easy, lightweight outline on this mesh. Let's go ahead and minimize that and jump into our scene view. So you can see on the sphere, it's working really well, but on the cube, it's not really working so well. Let's take a second to quickly analyze why that is. So on the sphere, there's a smooth fall off as the edge of the sphere goes further away from the center. So let's preview that with our Fresnel node. So we're just going to quickly grab this Fresnel, plug it into the emission, and drop our base color again. You can follow along here if you want. So you can see that as we go from the center of the sphere out to the edge, the Fresnel node fades out gracefully. For our cube, however, it doesn't really do that. It's either kind of exactly 0 when we're looking at it head on, or as we get kind of close to the edge, it really rapidly scales up. And so you can see that it applies basically for this whole surface. And so this whole surface will receive a sort of outline effect. We're just going to go ahead and drop that, plug this back into the emission, plug this back into the base color, save, and then go back here. And then we'll take a look at our custom material. Now you can see you can customize the outline thickness, and you can customize the outline color as well. You can see when you set it to black, nothing shows up. And when you set the outline thickness pretty high, it kind of looks like and that's just because we're using this emission value. So I think that's kind of a good introduction. So that's a quick introduction to Shader Graph for Unity 2022.3. So in this video, we learned how to make a shader graph, how to apply it to a material, how to expose different shader graph properties, how to sample a texture in shader graph, and how to use shader graph's Fresnel node to outline your model. Hit the like button and let me know if you'd like to see a full-on tutorial for shader graph in the comments. Thanks for watching, and I'll see you in the next video.